Yeah, okay. Is it on? Hmm, what can I see there? Okay, we're live, so that's a good sign. And today we're doing the Google Cloud Skills Boost. So that's the plan for this stream. And yeah, we can start now. Oh, I prepared the chart. As you can see, it's above the camera or the camera label. But yeah, let's go. So I'm starting from this second task: extract, analyze, and translate text from images with the cloud machine learning APIs. And let's come to objectives. In this lab, we will create a vision API, use the text detection method of the vision API, use the translation API, and use the natural language API to analyze the text. Next, setup and the requirements. Before you click the Start Lab button, read the instructions. I'm pretty sure I am I'm sure I've read that before, and we're all known with that. So yeah, activate Cloud Shell. It was prepared also. Okay, wait a second, create an API. Okay, we discussed that. So yeah, task 1, create an API key. To create, since we'll be using curl to send a request to the Vision API, generate an API key to pass in your request URL. Create an API key, navigate. So, okay, I have to open the Google Cloud Console. Wait, not this. Open in link in incognito window. Yeah, now use another account. ABD, okay, it is valid. Password, have to copy password from this tab right there that I like hidden from you. Okay, I understand. I agree, continue. So yeah, we are already on our student account, and now let's create an API key. Navigate to navigation mini APIs. So this is navigation menu. Now APIs and services. So that's there, and choose credentials. Click plus on create credentials, it's right there on this navbar, and select API key. Next, copy the key you just generated and click close. Copy, close. Now set the API key to an environment variable to avoid having to insert the value of your API key in each request. And also the environment variables. So, damn it. Where do we head now? Set the API key to an environment variable? What the yeah. Wait a second. What do we have to do now? Ah, okay. It's telling us how to do that in the second step. Run the following in the Cloud Shell, replacing your API key with the key just copied. So, okay. Open the Cloud Shell using button right there on this navbar, top navbar to be precise. So it's connecting here. Cloud Shell is opened. Now let's spell export API dash key equals and paste the current key and click check my progress to verify you performed tasks. Okay, I'm pretty sure we did that. So okay, task number 1 is done. So let's go further. Task number 2, upload an image to a cloud storage bucket. With a cloud storage bucket, there are 2 ways to send an image to the Vision API for image detection. By sending the API a base64 encoded image string or passing it the URL of a file stored in the cloud storage. For this lab, you will create a cloud storage bucket to store your images. Okay, so we use navigation menu, then cloud storage, navigation cloud storage, browser in the console, and then click create bucket. So create bucket. Okay, give your bucket a unique name. Okay, so I will copy that. Okay, after naming you click choose how to control access to objects. Click choose how to control. Okay. Uncheck the box for enforce public access prevention on this bucket. So enforce public access prevention on this bucket. So that's this option. Next, choose fine grained under access control and click create. Choose fine grained under access control. Fine grained. So that's this option. And click create. So that's this. Okay, great. Now, what now? Upload an image to your bucket. Okay, I guess I have to open this. Sorry, that's this page. Okay, open save images on the okay, it can be on USB drive. Okay, so I saved that on my PC, on my disk to be precise. And now navigate to the bucket. Shit, I should name this sign JPG. One more time. Save images. Sign dot JPG. I hope it's read that well. Okay, so now navigate to the bucket you just created in the cloud storage browser and click upload files, then select sign. Okay, .jpg. To the bucket just create the cloud store upload files. And damn it, I haven't saved that. Downloads. Okay. Now upload the images. Sign JPG. Okay. Yes. Okay, so it appeared on our list. So now, next you will allow the file to be viewed publicly while keeping the access to the bucket private. Click on the 3 dot for the image file, so it's right there. Then select edit access. Okay, and from now on, click add entry and set the following. So entity fifth should be public, all users, and the reader. Okay, save. Great. You will now see that the file has a public access. Now that you have the file in your bucket, you are ready to create a Vision API request, passing it the URL of this picture. Click check my progress to verify your performed task. Okay, let's see. Oh, file has a public access. Does it? Public to internet. So that JPG integrated cloud storage bucket. Damn it. I freaked something. Assign your JPG, click on the 3 dot for the image file, edit access, and then click add entry and set the following. Okay, one more time. Edit access, entity 5, it should be public, all user, and reader. It's at this tab. I don't know. This object is public and can be accessed by anyone on the internet. To remove public access, search for and remove all public entries from the object's permissions. Oh, damn. I love coffee. Save. Okay, so it's public. But where's my bucket? Have I deleted it? No, it's right there. Sign JPG. So that's the file I should upload to the bucket. So it's right there. So now let's see the task. Everything should be good. Now that you have the file, you are ready to create a Vision API passing in the URL of this picture. Click check my progress to verify a performed task. Check my progress. Damn it! Image sign JPG in the create a cloud storage bucket. Damn! That's my bucket. GCP certain bucket. Oh shit. What if the name is wrong? Shit. Bucket. Yes, select that one. And now configuration. And I have to change the name. Is it possible? Permission, protection, not, lifecycle observability, interpret operation. Operation is not there. Object. Copy path. No. Maybe right there. More action. Edit tags, labels, website, default storage class. Data export to cloud, pops up. Don't tell me I cannot change the name. It's mad. No, I don't get it. Export, process, delete, editor, default storage class. read bucket, now transfer data out, register job, edit access, edit labels. No, come on, edit. Website config. No. Okay, let's create new bucket. This time with correct name. So copy the name. Shit. Come back. Task second. QWE class. Copy the name without the dash bucket. Oh shit. Required? Okay. Choose how to control. Uncheck the enforce public access and find access control. To uncheck the box for enforce, choose find grade under access control and click create. Okay, that's it. And now upload files and sync. Don't don't tell me that the sign was misspelled, and that's the problem. It's ridiculous to think about it. Oh. Okay, and now we had to edit access, add entry of public, reader or users. Save. Come on. Check my progress. Yay. It's ridiculous. Really. Okay. No worries. Third task. Create your Cloud Vision API request. In your Cloud Shell environment, create an OCR request JSON file and add the code below to the file replacing my bucket name with the name of your bucket to create. You can create the file using one of your preferred command line editors, Nano, Vim, Emacs, or click the pencil icon to open the code editor in Cloud Shell. Ooh, damn it. Add the following to your OCR request.json. In your Cloud Shell environment, create an OCR. So I'm pretty sure we can use the touch command, OCR dash request .json. And then on file. Then add the code below, so we can use nano OCR. Okay. Add the following. Type. You're going to the text detection feature of the Cloud Vision API. This will run optical character recognition OCR on the image to extract text. Dope. Shit. Okay, everything good. Now Control and O to save. Enter. And now, can you even see the console? It's right there. Now Control X to exit. Okay, that's it. So we've written this script in the OCR request JSON. So what's next? Task 4. Call the text detection method. In Cloud Shell, call the Cloud Vision API with curl. So copy that script. The first part of the first part of your response should look like the following. Damn it. I'm so stupid. Let's edit this script. And you see the GCS image URI. I have to provide my bucket name. And I forgot completely about it. So copy the name of bucket and paste it right there. Okay, now save, enter, exit. And now the script should work properly. Okay. So data response, LABN, JI, some stupid, not stupid, like some random letters, but that's okay. What now? The first piece of data I get back from text annotations is the entire block of the text, the API found in the image. This includes the language code, a string of the text, a bounding box indicating where the text was found in the image. Wait, did it really found out it's French? Like, that's fine. Oh, okay, that's right there. The FR language code. That's pretty cool. Okay, for images with more text, the Cloud Vision API also has a document detection feature. This response includes additional information and breaks text down into page blocks, paragraphs, and words. Unless you speak French, you probably don't know what they say. The next step is translation. Run the following curl command. Save to the response to an OCR response JSON file so it can be referenced later. Okay, copy the script, paste it in the Cloud Shell, enter. And what now? The applicant data binary. Okay, I don't know. To save the response. Okay, save the response file. So now, if I want to preview what's inside the OCR response file, oh, it's saved actually. It's dope. So next task, send text from the image to the translation API. The translation API can translate text into 100+ languages. It can also detect the language of the input text. To translate the French text into English, pass the tag and the language code for the target language, English United States, to the translation API. Okay, sorry for the yawning. Let me take a sip of water. Now properties. Wait. Filters. No. Okay. Damn it! It's so tiring. Okay. Send text from the image to the translation API. Okay, so the first step is to create a translation request JSON file. Okay, oh, the clock. It's a translation request JSON file and add the following to it. Okay, so touch translation request .json, then copy this and nano translation, copy, save, enter, exit. Q is where you will pass the string to translate. Save the file, run this bash command in Cloud Shell to extract the image text from the previous step and copy it into a new translation request.json, all in one comment. What? Oh, okay, so I have to copy to extract it from the preset and copy it into a new. Okay, copy and paste str. So does it work? Let us see. Using cat command on the translation request. Okay, it copied actually. That's fine. Pretty cool. Now you are ready to call the translation API. This command will also copy the response into a translation response.json file. Okay, so copy this script or command, whatever. And now we call the translation API. Let's see have it worked. Has it worked? I'm pretty sure it didn't. Oh, sorry. Call the translation response. Okay, they're probably good. Dispatches for Obama. The mustard is from Dijon. Yeah, it worked. Actually. Wow. I'm really struck. Like, I'm impressed actually. It's doing a lot of things. So from now on, the translation API supports 100 plus languages, all of which are listed in the language support reference. I think we can showcase that. Language support. Okay, yeah, there's so many languages. 100 plus. Spanish, Hindi. Okay, let's come back to course. In addition to translating the text from our image, you might want to do more analysis on it. That's where the Natural Language API comes in handy. Onward to the next step. Okay, give me a second. That's audio. Okay. Okay. Wait. I think I... Give me a second, sorry. Okay, I'm back. But no. Okay, never mind. Everything works. So, after the short commercial break, let me spell it like that. Now, come to the task 6 and the last in this challenge, laboratory whatever you wanna name it. Oh, excuse me. Task 6. Analyzing the image text with the Natural Language API. The Natural Language API helps you understand text by extracting entities, analyzing sentiments and syntax, and classifying text into categories. Use the Analyzed Entities method to see what entities the Natural Language API can find in the text from your image. To set up the API request, create an r-request.json file with the following. Once again, touch, or it can be easier, just use the text editor, nano nl-request.json, and now copy the source, save and exit. In the request, you're telling the Natural Language API about the text you're sending. Supported type values are plain text or HTML. Content. Pass the text to send to the Natural Language API for analysis. The Natural Language API also supports sending files stored in cloud storage for text processing. To send the file from cloud storage, replace content with GCS content URI and use the value of the text file's URI in cloud storage. Oh shit. Then, encoding type tells the API which type of text encoding to use when processing the text. The API will use this to calculate where specific entities appear in the text. Then, second step, run this bash command in Cloud Shell to copy the translated text into the content block of the Natural Language API request. So copy, paste. Then the nr-request.json file now contains the translated English text from the original image. Time to analyze it. Call the analyze entities and post endpoint of the Natural Language API with this call request. So again, copy the script. Then, if you go to the response, you can see the entities the Natural Language API found. So let's review it from the top. And it is public good, order, common, proper, Obama, okay, I don't know, digit, location, begin offset, location, yeah, massage order. Okay, so it's pretty much sure it understands everything that happens in there. So then, for entities that have a Wikipedia page, the API provides metadata including the URL of that page along with the entity's MID. Okay, so the Wikipedia page is provided here in the Wikipedia URL field, and then the MID is an ID that maps to this entity in Google's knowledge graph. To get more information on it, you could call the knowledge graph API, passing it this ID. For all entities, the Natural Language API tells us the places it appeared in the text, the mentions field, the type of the entity, and salience, a 0 to 1 range indicating how important the entity is to the text as a whole. In addition to English, The Natural Language API also supports the languages listed in the Language Support reference. Looking at this image, it's relatively easy to pick out the important entities. But if you had a library of thousands of images, this would be much more difficult. OCR, translation, search translation, and natural language processing can help to extract meaning from large datasets of images. Oh wait, I have to breathe. So now on, click check my progress to verify you performed task. So analyzing the images text with the Natural Language API. I'm pretty sure we did that. Check my progress. Yeah, we done that. Congratulations, you've learned how to combine 3 different machine learning APIs. The Vision API's OCR method extracted text from an image, then the Translation API translated that text to English, and the Natural Language API to found entities in that text. You can use these APIs together to extract meaning from large datasets of images. Next steps / learn more. Vision translation and okay, then Google Cloud training and certification. Some data here, manual last update, And now? It's not better. Damn it! Yeah, so I don't know what's going on with the music and shit. And you barely can hear me, actually. Okay. Uh, how does it sound now? Give me a second. Now how does it sound? Cause I'm pretty much done right there. I thought everything was working perfectly, and it's actually not. Wait, let me hear the output. Okay, it's not bad, to be honest. But I have to lower volume of music a little. And yeah. So let's start with this second curse. And yeah. Damn it. Mute the stream. Okay. Let it play in the background. And start with the third lab actually of classifying the text into categories. Reload. How satisfied are you with this lab? Okay, the overview. The Natural Language API lets you extract entities from text, perform sentiment and syntactic analysis, and classify text into categories. In this lab, the focus is on text classification using a database of 700 plus categories. Come on, get off me with these comments. They ain't working. Never mind. 700 plus categories. This API feature makes it easy to classify a large dataset of text. Objectives. In this lab, you will learn how to create a natural language API request and calling the API with curl. Use the natural language API's text classification. Damn it! I don't want to leave any comment. They ain't working. Come on. Sorry. So objectives. Use the natural language API's text classification feature. And third is to use the text classification to understand a dataset of news articles. Then setup and requirements. Leave me. No comments here. Let me refresh the page. Okay, setup and requirements. Skip. We already covered that up. Task 1. Enable the Cloud Natural Language API. So press Start Lab. The course starts. Now, expand the navigation menu at top left of the screen. So we have to log on to our Google Cloud Platform student account. Oh, it's different account. Use another account. So copy the username on this tab that I covered from you. The student 03, blah 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 blah. Okay, copy the password. Okay, I understand. Welcome to a new account. Some pop-up will here compete. Okay, some country. I'm using VPN, never mind. I agree to Google Cloud Platform Terms of Service. Okay, I agree that my use of any Google Cloud services is subject to my compliance with the applicable blah, 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 something APIs. Start Cloud Shell. Okay, so now on second step, select APIs and services. Enabled. P. The API services. Okay. Now APIs and services, then enabled APIs and services. Click. What the something wrong? Okay. This is the current student. Okay, one more time. Navigation menu, APIs and services, enabled APIs. You need additional access to the GC. Not this project. Choose 03 project. Okay, I'm using the incognito page, but for some reason the browser remembered my old session and provided me the last project we were working on. I'm pretty sure it shouldn't happen, but life is life. Click enabled APIs and services, then click enable APIs and services on this navbar, then search for language in the search box. So let me spell language. Click Cloud Natural Language API is the top result. Now click enable. Where is the enable? API enabled. Okay. When the API is enabled, Google Cloud displays API information as follows. I'm pretty sure it's covered up. Okay, so come to the second task and create an API key. Since you are using curl to send a request to the natural language API, you need to generate an API key to pass in the request URL. So create an API key in your console, click navigation menu, APIs and services, then credentials. Got it. Then click create credentials. In the drop down menu, select API key. Next, copy the key you just generated. Oh, it's generated. Okay, so copy it, close. Click check my progress to verify the objective. Yes, we created an API key. Now that you have an API key, you save it as an environment variable to avoid having to insert the value of your API key in each request. In order to perform next steps, please connect to the instance provisioned for you via SSH. Open the navigation menu and select Compute Engine. Yeah, VM instances. Right there. Click. You should see a provisioned Linux instance. Yeah, it appears right there. And now click on the SSH button. You'll be brought to an interactive shell. Click on the SSH button right there. Okay. Be brought to an interactive shell in the command line. Okay, authorize. Okay, some SSH in browser interactive shell appeared. Oh, this is the Linux instance, and here below it's the Cloud Shell instance. So there are two different things. Okay, so as we on the Linux instance, let's export the API key. Export API key equals I'm pretty sure it's not this. Can anyone tell me, is this the API key that I was copying before? Yeah, that's not this. Okay, come to the APIs for a second. Credentials. Show key. Now, copy. Is it? Let me see the end. RIC. Okay, this is the same. So, copy. Let's copy it. RIC. Okay, it's the same one. Now let me cover this up. So open the Linux instance and now write the proper API key equals. Okay, we covered that. So we can come to the third task, classify a news article. And here, using the natural language API's classify text method, you can sort text data into categories with a single API call. This method returns a list of content categories that apply to a text document. These categories range in specificity from broad categories like computers and electronics to highly specific categories as computers and electronics / programming / Java, the programming language. So what? Sorry for stuttering. A full list of 700 plus possible categories can be found in the content categories page. Give me a second. I have to change my position. Okay, and next on we will start by classifying a single article and then see how we can use this method to make sense of a large news corpus. So first, to start, take this headline and description from a New York Times article in the food sections. So smoky lobster, salad, blah blah. Never mind. Create a file named request.json and add the code found below. You can create the file using one of your preferred command line editors. Nano, Vim, Emacs. Use the Nano. I like it, to properly say that. Nano request.json. Copy the so how to say that? Bro, my English is so dumb. The content Okay, set up the content of this file. Why do I forgot simple words like that? Okay, check my progress. Yeah, accepted. Step 3. Now you can send this text to the natural language API's classified text method with the following curl command. So copy it and paste this curl script. And now name. Now you can send this text to the natural language. Okay, so smoky lobster salad, blah blah. And it actually categorized something: food and drink, cooking and recipes, then food and drink, meat and seafood. Okay, that might be it. Was it? Was it classified and categorized already? Okay, that is okay. Some is powerful, like using, wait, cancel. I don't want to log out. Okay, where's the Linux instance? Right there. So as you can see, the API already, the AI categorized our content of the text with some confidence. And come on, what are the changes? I don't want to. Automatic refresh is really killing me. Then, okay, so you, as they tell, we created a speech API request, then called the speech API. What was that? Damn it. There's too much happening at one time. Okay, reload. Oh, it's signed out. Okay, never mind. If I need this account, I will relog anytime. Okay, run the following command to save the response in a result.json file. Again, the curl command. Not this time. Yes, reload. Okay, see ya. SSH. Okay, it copies some output from our previous API call to this result.json file. Now let's see, does it appear in this file? Result.json, yes, it got copied right there. So everything working. Now check the progress. Okay, yes, it accepted it. Now the API returned two categories for this text: food and drink, cooking recipes, meat and seafood. The text doesn't explicitly mention that this is a recipe or even that it includes seafood, but the API is able to categorize it. Classifying a single article is cool, but to really see the power of this feature, classify lots of text data. Next task, to classify a large text data set. To see how the classify text method can help you understand a dataset with lots of text, use this public dataset of BBC News article. Okay, something, whatever. What the? Connection failed? You can't connect to the VM instances because of an unexpected error. Wait a few moments and then try again. Seriously? And the retry button is not working. Refresh. Okay, that's an error. Probably I got signed out. for no particular reason. Okay, so let's see what is the next task. To examine the data and send it to the natural language API, you write a Python script to read each text file from cloud storage, then send it to the classified text endpoint, and then store the result in a BigQuery table. BigQuery is Google Cloud's big data warehouse tool. It lets you easily store and analyze large data sets. To see the type of text you will be working with, run the following command to view one article. GSO2 provides a command line interface for cloud storage. GSO2 cat, and that shows us some like BigQuery table for it creates the BigQuery table for data. Okay, so one more time, log into the account, copy password, enter Cloud Console. Now I want to open the, where was it? Compute. Then I forgot where was the Linux instance. Page credential, Navi compute engine, then VM instances. Okay, open the Linux instance. And then SSH. Okay, the new window pop-ups. Press Authorize again. Okay, and come back to the task 4. Now use this command gsutil cat. Okay, and this is some long text. Cat command just shows you a content of some file. In this example, it was some text stored on Google Cloud. Okay, so now we come to the task 5 to create a BigQuery table for categorized text data. And now, before sending the text to the natural language API, you need a place to store the text and category for each article. So now open the cloud, how do you call this? Google Cloud. Let's say Google Cloud panel, open navigation menu, select BigQuery in the console. Okay, BigQuery. Wait. Okay, some text right here. Press done. To create a dataset, click on View Actions icon next to your project ID and select Create Dataset. View Actions. Yes, that's the triple dots, and create dataset. That's right there. Now name the dataset news classification dataset. Let me copy that. Then click create dataset, so leave other options as default. Create dataset. Now to create a table, click on the view actions icon next to the news classification dataset, is right there, and select create table. Use the following settings for the new table. Create table from empty table. Name your table the article data. Now under schema, click add field. Okay, it's right there, and add the following three fields. Okay, three fields. One more. Okay, first one is article -text. Second is category. Third is confidence. String, float, all are nullable. Okay. Okay, everything properly. 8. Click create table. Okay, so the table is empty right now. In the next step, you will read the articles from cloud storage, send them to the natural language API for classification, and then store the result in BigQuery. Click check my progress to verify the objective. So we created a dataset in this task and table for the categorized text data. Next, task 6, classify news data and store the result in BigQuery. In order to perform next step, please come to the cloud share. If prompted, click continue. Now, so we ain't using the Linux instance, we come back to the cloud shell. Before writing a script to send the news data to the natural language API, you need to create a service account. This will be used to authenticate to the natural language API and BigQuery from a Python script. Step 1. Export your project ID as an environment variable. Okay, export project, paste it. So yeah, we set up the project ID into the environment variable. Next, run the following commands to create a service account. So I guess we have to copy all this bunch of code. Scripts, it should be better named. gcloud time service. Okay, some service, some keys, some environmental variables, etc. Okay, now authorize cloud shell. Press authorize. Oh, error. Press, which is the active specifier? What? This is the... What the... Okay, student 03. How is that possible? That... No, not this one. Do you see that? I am on the... my latest project I was working on in the before lab. That's weird. That's actually weird. Okay, never mind. So close the old project, come to the new one. Now export the... I hope... Oh no, the before task I was doing on the Linux machine, so there shouldn't be any problem. So now that copy every content from the bunch of scripts. Now this gcloud, the authentication. Okay, now we get response that the service got created. Yeah, service account got created, sorry, it's a difference. Okay, so now we are ready to send the text data to the natural language API. Now the step is to write a Python script using the Python module for Google Cloud. You can accomplish the same thing from any language, from any language, and there are many different cloud client libraries. But the goal is to use Python, I guess. So we create the classify tag minus text.py and copy the following code into it. So the code is pretty strong. Let's quickly drive through the content. Let's read what it's all about. From Google Cloud, import storage language and BigQuery. Create this storage client instance, the language service client, and the BigQuery client. Okay. And now it was the natural language from what I remember. Okay, search time, dataset ref, then send article text to the natural language APIs method, classified that uses classified text, some function, some rows, storage client bucket, blobs. Blobs are some part of function. From what I remember, the blob in one of my projects I was sending blobs. That is a what are the blobs? Blobs are some part of some bits combined, something like that. I'm not sure. Then send files to the natural language API and save the result to send to BigQuery. Okay, it's written right there. Then print, write article text plus category data to BigQuery. Okay, so now the goal is to copy that, paste, then save and close. And now we are ready to start classifying articles and importing them to BigQuery. Just run the following script. So use the Python 3 classify -text.py. Okay, got article files from Google Cloud Service, sending them to the natural language API. This will take around 2 minutes. Great. So this script takes about 2 minutes to complete, so while trying to read about what is happening. You are using the Google Cloud Python client library to access cloud storage, the natural language API, and BigQuery. First, a client is created for each service, then references are created to the BigQuery table. Files is a reference to each of the BBC dataset files in the public bucket. The files are looked at, the articles are downloaded as strings, then each one is sent to the natural language API in the classified text function. For all articles where the natural language API returns a category, the article and its category data are saved to a rows for BigQuery list that says some row name in the table. Then when classifying each article is done, the data is inserted into BigQuery using insert rows. Note, the natural language API can return more than one category for a document, but for this lab you're only storing the first category returned to keep things simple. Then, when the script has finished running, it's time to verify that the article data was saved to BigQuery. In BigQuery, navigate to the article data table in the Explorer tab and click Query, then in New tab to Query Table. So, okay, as we can see, writing this script has ended. And now in BigQuery navigate, so open up the BigQuery, we are in the BigQuery Studio. Then what you can see, okay, choose article data, then query, and in new tab option. Edit the results in the unsaved query box. Adding an asterisk between select and from. Okay, add asterisk right there. Okay, there is limit 1000. They don't have it. And now click run. you will see the data when the query completes. Okay, so we have some result right there. Let's see something. India calls for fair trade rules, etc. Never mind. Then category, law and government, and confidence of that 0.84. Not that precise, but it's pretty impressive, I have to say. There is something of Peugeot deal boost Mitsubishi. This is categorized into autos and vehicles, and the confidence on that is near to 100%. Wow. So scroll to you will see your data when the query completes. Then scroll to the right to see the category column. This is category column, and we see everything. Then some text. The category column has the name of the first category, the natural language API returned for the article, and confidence is a value between 0 and 1, indicating how confident the API is that it categorized the article correctly. You will learn how to perform more complex queries on the data in the next step. Learn how to perform more queries on the data in the next step. So, task 7. First, see which categories were most common in the dataset. In the BigQuery console, click plus create SQL query. Okay, BigQuery console, where is that? BigQuery console. Am I dumb? BigQuery console. BigQuery console, click create. Okay, create SQL query. I guess this is that button. Okay, we have nothing to lose. Then enter the following query. Okay, select. Let's see how is it fine writing the category count asterisk C from some dash. How do you make the quoting sign? I'm not sure. You can tell me in comments at some point. 036584551 adcc news classification dataset article data and quoting, then group by category ordered by. See this. Now click run. You should see something like this in the query results. Okay, every category drop right there. And now see, DC is a count, so the news and politics come out as the top results with 20 appearances. Now, if we wanted to find the article returned for a more obscure category like arts and entertainment, then dash music slash, I should say, slash music and audio, then one more slash classical music, you could write the following query. It's select asterisk from, so copy. Okay, let's see, can we comment the whole query? Of course. And now copy the new query of the more detailed article. Now run. And what do we get? We get one article about this specific category, and it appears only once in the whole table data BigQuery. That's not the point. Use the natural language API text classification method to classify news articles. And that's it for this stream. I have to end now because it's pretty late. Thanks everyone who joined, everyone who was watching. And yeah, that's all. See ya.